Alright, in this video we're going to look at a process called factoring. Now factoring is going to help us to solve quadratic equations, but before we actually do the process of factoring, let's talk about what factoring is. So factoring would be the way that we get from this expression, in this case it is a quadratic expression. We could set it equal to f of x or equal to 0. It would be a quadratic function. This factoring is the way we get from here to here. Now, the most basic way of explaining it is that factoring is the opposite of the distributive property. Hopefully you understand that with the distributive property we could take this 2x times 3, 2x times 1, 4 times 3x, 4 times 1, simplify that, and we would end up with this polynomial. Factoring is the opposite of that. Factoring is a process that takes us from here to here. And when we start solving the quadratic equations, it'll make sense as to why this is important and why this is a necessary process in solving quadratic equations. But before we do that, let's kind of take a step back and look at some other examples of inverses and how that works, just really quick. So addition and subtraction. 7 plus 2 is 9. We can do that backwards and say that 9 minus 2 is 7 because they're inverses of each other. We can start with something, do that, do the opposite, and get back to that same term that we started. Works the same way with multiplication and division. 10 times 2 is 20, and then we can take that, do the opposite, divide by 2, and we get right back to 10. So we're starting and stopping with the same thing if we do the inverse. The same thing works with distribution and factoring. So I want to take this example here and distribute, get our new polynomial, and then we'll take that polynomial, factor it, and get back to the same thing. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. 2 times x is 2x. And 2 times negative 4 is negative 8. Now, we combine our like terms. We have a couple like terms here. Negative 12x plus 2x is negative 10x. And then we have our minus 8, and we bring down the 3x squared. What I want to do now is take this polynomial and look at the process of factoring, and if we do it right, we will end up with the same thing that we started with over here. So, looking at the process of distribution, we have kind of two main steps. We have a step of multiplication, and then we also have a step where we add and we combine like terms. To factor, we're going to do this process going in this direction. So the first thing that we need to do is get back here. Well, the way we're going to do that is we first need to recognize a pattern that occurs within the distributive property. And what happens here is that these middle two terms have the same product as, let me do that in a different color actually, as the outside terms. They have the same product. So negative 12 times 2 is negative 24, and so is 3 times 8. And even as far as taking the variables into consideration as well, negative 12x times 2x is negative 24x. 3x squared times negative 8 is also negative 24x. So what we want to do is take these two terms, multiply them together. It's negative 24, and really I just worry about the coefficients. And then list all the possible factors of 24, because when we split this back into two terms, that's what we want to do. We want to split it back into two terms. It needs to have the same product as 3 and negative 8. So we have 1 and 24, and obviously one of these is going to need to be negative. We could do 2 and 12. We could do 3 and 8. And we're just looking for one of these that we can combine and get negative 10. And that's going to happen right here. If we have negative 12 and positive 2, that's going to be negative 10, which is what we had over here. So I'm going to split this up. Negative 12 plus 2x, and then minus 8 3x squared. So this step right here is really important. This is the step where we split that middle term back into two terms. And then once we split that middle term back into two terms, we can group this together in a way that will allow us to factor with less terms at a time. Rather than trying to factor 3, we're going to group it and factor something out of here and factor something out of here. The goal will be that when we factor something out, what's left is the same thing. So what are both of these divisible by? Well, 12 is divisible by 3, so we can definitely pull out a 3, and they both have x, so x squared and x, so we can actually pull out a 3x, and that will just leave us with an x and a negative 12. I'm sorry, not negative 12. 12 divided by 3 is negative 4. I'm going to scoot this over a little bit. So we pull out a 3x, and we're left with x minus 4. So 3x squared divided by 3x. 3x squared divided by 3x is x. Negative 12x divided by 3x is negative 4. Now we're going to do the same thing over here. They're both divisible by 2. So 2 divided by 2 is 1. 8 is also divisible by 2. This is a constant, so we can't pull out an x this time. We're only going to pull out the 2. And it's going to be a positive 2. So I'm going to say plus 2. 2x divided by 2 is x. And negative 8 divided by 2 is negative 4. So like I said, we needed to have happen. We ended up with the same thing here. So now we can rewrite this as the original polynomial that we had to begin with. We have 3x plus 2. And this is just the distributive property that allows us to do this. And then we have x minus 4. And that is this factored. And that is the process of factoring, how we take that polynomial, that quadratic trinomial, what will look like a quadratic equation, and then we can factor that out. So this was looking at the distributive property and factoring side by side. Now let's look at a problem that we don't know what the original factors were and factor it out. So in this example, we'll take 6x squared plus 14x plus 4, and we'll factor this out. So the first thing that we need to do is multiply a and c together. So 6 times 4 is 24. And then we're going to list the factors of 24, looking for a pair of factors that can get us to 14. So 24, we have 1 and 24. We have 2 and 12, 3 and 8, 4 and 6. So we're looking for one of these again. That will get us to 14. 2 plus 12 is 14. So 6x squared plus 14x, plus 12x plus 2x plus 4. And this is the same thing. Again, all we have done is we've broken this 14x back into two terms so that we can group it together and factor out. So both of these are divisible by 6. They're also both divisible by x. So I'm going to pull out a 6x. That will leave us with an x plus 2. 6x squared divided by 6x. 6x squared divided by 6x is x. 12x divided by 6x is 2. And now we're going to factor over here as well. I'm going to switch colors so we can tell the difference here. So both of them are divisible by 2. This is a constant, so we can't divide this one by x. So we'll just pull out the 2, positive 2, so plus 2, and then we have x plus 4 divided by 2 is 2. And again, we ended up with the same thing here on the inside for both of them. That's what we want. So our solution is 6x, or not our solution, but our factors are 6x plus 2 and x plus 2. And if we wanted to prove that, we could distribute here and make sure that we got back to this original polynomial. But these are the factors. Now we're going to look at the importance of this and why factoring helps us solve quadratic equations. So first of all, if we think about the graph of a quadratic equation, what we call the solutions are the places where that graph, so quadratic equation is a parabola, are the places where it crosses the x-axis. Anywhere it crosses the x-axis, that's what we call a solution. Now, if we think about all x-intercepts, what they all have in common is that the y-coordinate is 0 for all of them. Let's say this one is 2, 0. We'll call this one over here 1.50. It's just arbitrary for now, but the point is that the y-coordinate is 0. So if we set this equal to 0, because a function is equal to f of x is what f of x is the same thing as y. If we set that equal to 0, we should be able to solve this and find the places where it would cross the x-axis. So when we talk about solutions for a quadratic function, what we're asking for is where does it cross the x-axis. That's what the solutions are. Now, the thing about multiplication is if you multiply anything by 0, you're going to end up with 0. So if I were to do 0 times x plus 2, that would equal 0. Or if I did 0 times 6x plus 2, that would also equal 0. Meaning that if either of these are 0, or both of them are 0, the whole thing will be 0. So the way that we're going to solve this is by setting each binomial equal to 0. So we'll set each of them equal to 0. 6x plus 2 equals 0. X plus 2 equals 0. And at either of these solutions, this graph would cross the x-axis. So we'll solve both of them. Minus 2, 6x equals negative 2. Divide by 6, x equals negative 1/3. And for the graph, what that would mean is that at negative 1/3, it would cross the x-axis. We can do the same thing over here. Minus 2, x equals negative 2. So also, at negative 2, this function would cross the x-axis. And as we continue in section 4 and then get into section 5, we're going to start solving these more and then start graphing them more. You actually see the application of these solutions, of these x-intercepts. But for now, we're going to focus on the arithmetic and focus on finding these solutions by factoring.